Okay, so the more examples we do, the better, right? So let's look at even more examples. And this is an interesting one, as this illustrates another theory, another application, I should say, of what we have, of the theory that we've learned. It is a very important application of how long does it take to brake a car, and especially if we drive a lot. So let's look at a problem first. It says an inattentive driver is traveling at 18 meters per second. You can transfer. I'll challenge you to put down in the comments below, or let me know what is this in miles per hour or kilometers per hour, so you get a good sense of how fast that is. When he notices a red light ahead, his car is capable of decelerating at this rate, 3.65 meters per second squared, and it takes him 0.2 seconds to even get the brakes on, right, to realize that. And he's 20 meters away from the intersection when he sees light. Will he be able to stop in time? Okay, so how to approach this? So this is this brings us to actually realize that let's go back to the big screen if we can. Let's draw out the situation, what's happening, right? So let's say this is the intersection, right, where this is where the lights are, okay, and you are 20 meters away from it. And what happens is you need to first realize that in the first certain amount of distance, you're still reacting it, right? So this is the reaction time. And this is in these type of studies, it's called the thinking distance or the reaction distance. And this is the braking distance. Right? The thinking distance is the distance that it takes for the driver to react to there is a light. All right. So normal human times, reaction time. So it's the time it takes to react to the light. Right. The normal human time is roughly 0.1 to 0.2 seconds. Okay. So let's say this is on the far end. It's 0.2 seconds, and you will have traveled a certain amount of distance before you even put your brakes on, and then the rest is the braking distance, right? So the theory is a very simple equation that says the stopping distance is the thinking distance plus braking distance. Okay, so this is how it works. All right, so how do we analyze this? Now, notice then we have two steps over here. If I bring this up again, because at first you have traveled a certain amount and then you travel the rest of the distance. So we actually have to split into two parts of the problem. Okay, so over here, the time is time taken is 0.2 seconds. All right, and we don't know the rest over here. All right, so there's two segments over here. So we should distinguish them with T1 and T2. Okay, so let's enlarge this a little bit. I'll call this T1, T2, or the time it takes for the thinking and the time it takes for the braking. All right, what do we know for each? Okay, so for, let me write it underneath here. All right, so I'll write SUVAT over here. And I'll put a 1 over here because I need to find the SUVAT variables for the second part of the situation, because there's a change in acceleration. Okay, so what are other informations we know? Well, initially here, we know the velocity is 18 meters per second, right? And what's the acceleration in the first part? Well, the driver is not reacting, right? So let's assume he's going at constant speed. He's not accelerating or slowing down. He hasn't put his brakes on yet. So the acceleration over here is, oh, that should be U because it's initial, is 0, all right? And then here, we're capable of decelerating at 3.6 meters per second squared. Now, what am I missing for that A2? That's right, the sign, right? Because I'm moving to the right, and the sign is going to the left, but left and right, or positive and negative, only makes sense if I have a system, if I have a coordinate axis. So I'm going to call that the positive x-axis, and this is going to be my origin, like that. Okay, so in the thinking distance, what do we know? We know that's 0. The braking part, we know this is minus 3.6. That's when the car brakes. We know the thinking time was 0.2 seconds. We don't know the v. Yet. We don't know the S, the U is 18, right? Okay. Now let's think about it. Do we actually know V? Yes, because this is 0. So it's not accelerating. So if the initial speed is 18, what does that mean about my final speed over here, V1? It should be 18, right? Now, if you don't realize that and you just go in and plug in the equation and go like, all right, I want to find V1. So in fact, remember, if you have 3 of the 5, you can find all 5. So let's find one without S and then try to find V1. So which of the kinematics equation, SUVAT equations without S? This one doesn't have S, right? So you plug in, but A is 0. So U equals to V. So even if you did not realize that, you go, duh, I don't, you would realize, oh, it's just 18, right? So you can say by common sense, if that's 0, that's 18, or you can go like by the first kinematics equation, I can calculate that. Right, okay. Let's see. So do we need to find this? If you're not sure, there's 2 strategies. You can find it anyway, or just keep going and see what you need. What is our aim, by the way? Let's not go aimlessly in the forest, right? We want to know what we're trying to find. We want to try to find if we can stop in time. So in other words, I want to find the total stopping distance, right? If I want to find out how far it would, when I'm traveling at 18 meters per second, how much how much distance or displacement have I traveled in the thinking part, and how much distance in the braking part, and is that more or less than 20? That's my goal, right? So in essence, I want to find S1 plus S2, right? The displacement from thinking and the displacement of the car from braking, right? And we want to see if that's larger or smaller than 20 meters. That's our goal, all right? So this is the goal. So in fact, now that you have an aim, you won't be aimlessly in the forest, right? You know exactly what you need. In fact, you need S. I don't really need V, but well, yet, but I know I need S. All right, pick your favorite one to find S. Anyone would do, actually, except for this one, because that doesn't have an S. Which one is the simplest? Usually that's my reaction. If I have choices, find the simplest one, right? That looks like the simplest one. So we have U and V, right? So we can do, I'll try in a proper presentation, try to write it linearly. This is more like a scratch work. So I'll put my steps a little bit all over the place, but you get the idea, so I can keep more information over here for your benefit. So S1 is going to be U1 plus V1 over, so that's the first part, right? Over 2 divided by, times T1. U1 and V is 18 plus 18 divided by 2, so that's just 18 really, times 2 divided by 2. T is 0.2, and that means S1 is 3.6, right? So put that in a calculator, double check my math. And what is the units? It's meters. It's positive. Does it make sense? Right? Remember, check 3 things. I'll write it in different colors. Check. The positive, negative, does that make sense? Do you have to reject anything? Check significant figures and check units. Okay, so in the problem, I'm given 3 significant figures. So we'll stick with that, even though in the in exam, we won't worry too much if it's just significant figure off, but units is important, right? So, but just for teaching purpose, let's be rigorous about this, right? So 3.60. But it's not even a final answer, so I don't have to worry about the significant figure. It's really just the final answer to worry about that. All right, so let's copy this over here. I have found this to be 3.6. Okay, that was actually a deduction, right? So I've deduced that instead of that being given. All right, so now the second part. What else do I know? Do I know the time? I don't know the time. Do I know the initial speed? Well, it sounds like I don't, but if you think about it, this is the same transition, right? So the final speed or final velocity of the first part should be the initial velocity of the second part, right? It just continues on, right? So it just matches on. So I do know this is positive 18, okay? So the first part, there's no acceleration, so it really just stays as 18 meters per second, right? Oh, sorry, I almost forgot to comment. Plus and minus, does that make sense? Positive, I'm defining x as positive that way. So yes, it does make sense. The displacement being positive. And all right, what else do I know? I just have 2 out of 5. That's not good. We're very close. Remember, we need how many? We need 3 out of 5 in order to do anything, right? So we need one more. I don't know that. Do I know this? What am I given? Right? So let's look at that again. Well, we wanted to be able to stop. So what does that tell me about, what does that tell me about V? And tell me, I want myself to stop. So that should be 0, right? Okay, now I have 3 out of 5 and I'm good to go. I could go ahead and find T if you are being, if you have a lot of time on your hand, and if it's good practice as well, just to get yourself more familiar. But I'm going to go straight to the point. I'm going to find S2 because I want to find the stopping distance, and I need to find one without T. So which one's without T? That one, right? So we'll use the fourth equation, and we'll do it here. So V squared equals to U squared plus 2AS. U is, again, this is, everything is in the second segment over here. So U is 18 squared plus 2AS, right? So 2A is the deceleration, so minus 3.6. So you would always want to double check your signs, S like this, and V is 0. Our goal is to find S2, so put S2 over here, and I have 18 square divide by, right, so move that over here, divide by 2 times 3.6, right? And now we can pull out our trusty calculator and go to 18 square, sorry, 18 square divide by 2 times, remember brackets around that, or divide twice that. So I got 45. You can double check if that's the same thing you get over there, and check 3 things, right? The sign, is it positive? So I got positive. Does that make sense? It makes sense, right? And then I want to check significant figures. All right, add a 0 and units, meters. Okay, so what's my total stopping distance? Well, looks like my total S total, which is S1 plus S2, is 3.6. That's the thinking distance, plus 45, and that will give me, I'll just write it horizontally, usually going vertically is better for presentation, 48.6 meters. And that's 3 significant figures, looks good, right? Okay, did he stop in time? I don't think so, right? All right, so again, tragic end aside, hope you're happy about how to solve this. If you have any questions, let me know either in the comments below or anywhere in any of our course platforms. All right.